it's Siddharth, and I'm back with another video. And today's topic is quite different and interesting, also, because today we're gonna build a conditional GAN, conditional generative adversarial network. Sounds crazy, but it actually it is. It's super awesome. Like if you give it an image, let's say a sketch or a facade image, and you give a reference image, it will try to find a correlation between the two, and it will generate something different which does not exist in the data. Like it can be used to build designs. It could be used in making concept arts. You can just expand its potential up to the point you want, in the way you want. So without wasting any time, in this video we're gonna load in the images, the data images. We're gonna process that into next video because I'm not gonna extend this too long, or else we'll be tiring. So go to Chrome. I'm gonna go to mine and open your sign in with your account and right click. Come on, man. What happened? Wait a minute. Yeah. Sometimes it's with the internet. I want my face to come up. So go to more and collaboratory. And now we have the good stuff going on. So yeah, it's okay. We have it. We have it right there. And did I mention that we are going to build this in TensorFlow 2.0? Not 1.0, 2.0, the latest version of TensorFlow. So don't worry, we are going with the trend. Yes, of course. So hit connect to connect your notebook. Okay, it's connected. Now what we need is, of course, we need our dependencies. So import your dependencies. Sorry, your dependencies, or whatever. Let's say your libraries. So we need from future import absolute import. That means we're gonna need everything from this library. From import, come on, from import absolute import. Then we need division. We need print functions for various print functions to use the various print functions, because there's in Python you have one type of function called print, and then parentheses, then other code, and just write the string statement or the segmentation you want to print out. What we're going to use is we're going to use like print image, print array. So there are many different other print functions which we can extrapolate it from the future library, I guess. Yeah, that's how it works. Yeah, this is how it works. Function, and then we need a Unicode. So to decode it, Unicode for Unicode literals. So we need this to convert it into the low-level language, like to convert it into the language in which a computer will be able to understand. So Unicode, we're just gonna encode the input arrays, image arrays, basically. Then we need, first up, we need something else also. We also need, we need get the access from our Google Drive, because we have folders stored in. So I'm not gonna type this, I'm just gonna copy and paste everything what I have in here. So I was using this in another project from Google Colab. Yeah. So I'm gonna click this, paste it in. So yeah, once we are done with that, we're gonna hit pip install q TensorFlow. It's TensorFlow GPU, and yeah, I'm sorry that I didn't mention this one. Go to edit, go to notebook settings, come on, go to notebook settings and choose hardware accelerator to GPU. That's the, you know what, this is the main advantage of using Google Colab, because you can use GPU, which I guess what they are using is GTX Tesla P90, which is designed specifically for high level computing, like deep learning computing. So I think it's great. So say that it's gonna reconnect it, and meanwhile we're gonna type in our code. So it's 2.0. It was alpha, but now it's been converted to beta version beta. Sorry, what am I saying? Version beta. Then we need, of course, import TensorFlow. TensorFlow as TF, as always. I want to say import OS so that we're gonna extract the data from um, the directory of Google Drive. And if you're running this on your local machine, you can still use this. So this code is universal. Like you can use it in your computer, you can use it through Google Colab, you can load in your Drive directory. It's 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 like platform agnostic. You can use it anywhere you want. For time, so we're importing time so that we can keep a track how much time it took for training the model. Matplotlib, so to plot out our results, the images basically. So it's not gonna be like number output, it's gonna be actual image. Not joking. If you don't believe me, you can go to Instagram and see the result. I've shared a post where it says why to why to jog your brain if AI can do it for you, for design basically. So I'm working on a startup, so yeah, it's fairly relatable. You can relate it through this. The clear output. Okay. That sounds cool. Okay. Good. So I want to go through here. So I'm already training one of my model in the browser. So I've already logged in. But if you want to log in, it will give you a link. You just go to there, copy paste your key and paste it in. Copy your key and paste it in, and it will mount your drive. Now we need to install a TensorFlow, which is requirement satisfies. Option is G. Okay, I'm sorry. This should. Why do I perform such stupid mistakes? Okay, we are humans. Okay, it's okay. The meanwhile, it's the okay. While it's doing this installing stuff, meanwhile we can proceed to the code. Now the fun part comes in. We're gonna load our dataset. So I already have a URL for facet data. This what it has is it has a facet. Let me just show you the demo. Let me show you the data type of data I'm talking about. So the software development. Basically, I'm gonna say Python.ai, like Python AI. It's gonna show up. Come on. Okay. Yeah. And we have it. Yeah, conditional GANs, facets. So let's see the train data. So these are the images. Come on, I don't have time. Come on. So at one side you have the facet image, and one side you have the actual image, like the actual building image. So this facet is generated from this real image. So we're gonna use these type of images as our data. You can use the sketch images, no restrictions on that. Depends all on you how you're gonna use this. I'm gonna say path to zip. Sorry, to zip equals to tf.keras dot utils dot get file. So I'm gonna get this file from this link. Okay. Yeah, it's pretty good. So facades. Okay, I'm going great dot gz. So we are getting this file from this. We're getting this chart dot gz facades file from this link. I've posted this link into the description, so don't worry of copying this whole thing. So we need origin to be origin. So don't manipulate this part, these type of variables, because this is keyword. This is a keyword instance. So I want to extract. I want to set extract to true. So true. Once that's done, I'm gonna say path equals to os.path. Remember we imported os library. This is what I wanted. Dot join os.path dot journey, then path to zip. I'm gonna just copy this and paste this in. Path to zip. Let's say facades. Yeah. Sorry, that was my. Okay. Yeah. Cool. So yeah, I have a phone right over here for any purpose. Oh yeah, where were we? We were writing the code. Yeah. So let's run this. See. Okay, no errors. It's not showing the download section because I've already downloaded it. It takes a long time. Depends upon the data. Depends upon the machine or you can say the network you're using. I'm gonna say set the buffer size to 400, and I'll tell you what buffer size is used for as we go into the code more deep. As we go on to this code, to this tutorial, to this series, you'll get what buffer size is. Basically, the buffer size we use it for is for the intervals to load our images. That's, I think, what we use it for. That's what I use it for. Let me find a correct explanation for this, and I'll let you know in the next video or so when we'll come to this point of using this variable. So we have our variables. Now we need. So this is the fun part. We're gonna load our images, and then we're gonna plot this. So this is a really small, sensitive bit of code, and let's do this. And then we're gonna end this. Yeah. Because I'm not going to make this tutorial big, big. I mean, with the big is 1 hour, 2 hour tutorial, because it makes you boring. I know it feels boring. And what I recommend you to do is watch this video in 2x speed to learn more faster. That's what I do. Whatever the video I watch or lecture I watch on YouTube, I just make it 2x speed to learn more faster, to grasp more faster. So enough talk. So image equals to tf.io.read files. So we're gonna read through the image file we have. Then image equals to tf.image.decode JPEG. So basically these are in JPEG format. JPEG image. Let's say w equals to tf.shape equals to image. Then we'll say 1, because we're going to take one image from the data. We'll say w equals to w divided by 2. Say real. So the real image will be printed. Let me show you once the output is out. It will be once the output will be shown. Once the output will be shown to you, it will be basically it will be easier for me to explain it to you what this part means. like what I'm typing right now. W, it's done, yeah. This part, yeah, that's what I was talking about. Input image equals to image equals to, okay, W, and we need this, and we need this too. That's right, we need this too, yeah. So we are almost done. So input image equals to tf dot cast, input image tf dot float 32, and I want to say real image equals to tf dot cast. Let's say real image equals to tf dot float 32. So this is an instance of TensorFlow. We are creating a float instance on the real image and the input image. I'm gonna casting it out. Then return input, and what's a mess of what's I don't know what's up with my voice. Image equals to, and we're gonna return real image and input image. Once that's done, and put no, that's not right. The image, yeah, sorry. Once that's done, I'm gonna now we're gonna print this out. We are going to uh, plot this images. So load function, remember we just made it right now. We made it right now. So image file, whatever file comes into the path is gonna take the reference. The image file is gonna so the image file is gonna take reference from the path. So let me just show you a demo. So path, we're gonna concatenate train directory, train, let's say 120 point. This is image name, so JPG. Now we need to cast to int, like we're gonna cast the image to int for matplotlib to show the images. Okay, plt.figure, I'm gonna say plt.im show. So IM say INP, no, we just created a different way, INP divided by 255.0. That's the width and height, basically the width of input image, basically the width and height of width and the length and breadth of the image of input image. Yeah, that's right. Okay, sometimes I just messed up with these terms. plt dot I'm show. What the heck? I'm show. I'm gonna say I'm gonna say this as re. You can name this anything. I'm gonna say it re. You can say real, whatever you want. It's up to you. 0.0. Okay, let's see. Let's press it out. Okay, we have loaded our images successfully. So I'm gonna end this tutorial right now, and because the next part of the code is fairly big and will take a bit more time, and I want to keep this short and simple for you to get, so you'll find it what I'm saying, you'll find it easy to learn. Basically, if it's, I don't know how much minute it took. It started in 8:50 or so. Now it's 9:12 Indian time. It's Indian time. So yeah, around 22 minutes, basically, with the explanation. And so yeah, that was it. And basically the URL for the data, I'm gonna provide this URL in the description box. Like, you can just copy and paste it into your collaboratory notebook. And if you remember from our last video, I talked about making a chatbot. See, I'm working on it. So the chatbots which are available is in PyTorch, and it's really long code. Like, it will be tiring, it will be boring, and there will be tons and tons of explanations just for one single project. Like, it will take 1,200 lines of code to build in chatbot in PyTorch with the available sources. What we can do is to create chatbot. We can create it in TensorFlow 2.0, just like that. So I'm working on it. I'm developing my chatbot 2.0. Yeah, chatbot 2.0 version 2.0. I'm gonna show you to you. So yeah, that was it. That was all about pix to pix algorithm part one, loading our dataset, basically the images. So goodbye, happy flying, and subscribe to my YouTube channel. If you like this video, leave a thumbs up. Hit the smash that thumbs up button. You just smash that thumbs up button, and also smash that subscribe button, the red one. And if you find any difficulty or any problem related to any kind of deep learning or machine learning project, or even from designing in ZBrush or Maya, you just contact me, or comment in the comment box, or I will leave a email link and my personal number in the description box. You can contact me through there. So that was it. So happy programming, happy flying, and be creative and start thinking for new ways of possibilities of and start making new projects on your own. Wait, that was necessary, was it? Okay, so you got the point. Good night, sleep tight, and I'll end this video right now. Thank you for watching my video, and as always, hit the like button, smash that subscribe button, and stay tuned with the future project and also the part 2, part 3, part 4, and several parts of this project until it isn't complete. It's complete. Ted, stay tuned. Stay tuned. Bye bye. Good night.